Hi, Dr. Smith. This is Steve Stilson. It's so great to finally be able to address you personally, even though it is via webcam. But I wanted to show you this really cool visualization that I have made, which makes it easy to compare all kinds of African American attributes, including by gender versus white enrollments in all public universities using Arbor JS. I've created a project from scratch using Arbor that'll make it very easy to visually see all of the different attributes describing all of the universities nationwide. I wrote 99% of the code myself, including several JavaScript functions from scratch. My project is here on GitHub, as you can see, so I'll go ahead and click on it and then you'll be able to see the code. I chose Arbor JS because of its great use of physics and built-in springiness of the nodes. When they are created, they pop out of other nodes and naturally move to spots of equilibrium across the screen. But I didn't find out until later that Arbor was one of the most difficult graphing libraries to use. And while I described that, I'm going to go ahead and start it up here in Eclipse in the background. So I spent weeks trying to get it to work with MongoDB and failed. I also wasn't able to get it working with as a Node.js application either. And then I had an issue with Eclipse's built-in browser not updating as well. According to this website, of all the physics simulation libraries and layouts that exist in JavaScript, you've chosen pretty much the worst one. Arbor JS probably is tied with Spring for being the most primitive, least efficient, and least aesthetic. Further, Arbor itself has been abandoned by its author. That's a direct quote. But after much trial and error, I was finally able to code an application where you can browse the data and search which schools start with a certain letter, see their enrollment data by race, and then compare them by enrollment numbers via race and gender. Most importantly, you can use my application to see all schools that share certain attributes. For example, you can cross-reference which schools have similar percentages of just African American women, or if you want to see all schools that have very low levels of African American men, less than 5%, you can do that. So for example, let's go ahead and at this, I'm going to copy the URL and then paste it in. Okay, you see I have my own URL up there, which is localhost:8080/CS235 visualization. So I'm going to put it into that it is executing off of my server. So here you can see the natural springiness of the nodes, which is really cool, and it is one of the things that made me want to choose Arbor. So let's go ahead and choose a letter, and it'll tell me which letter I have. I'm looking for A or B or C. I don't see them here. Oh, no, that's A. Okay. So it tells me I chose A. I found 56 universities that begin with A. And I've put a limit of 30 on the screen, otherwise it gets way too busy. See here, it's even a problem with the 30. But it'll spring down and then spring back up. And here's all of the first 30 schools that begin with A. So let's go ahead and choose one. For example, Athens State University. Yes, these are all the different attributes of Athens State University. White 618, men 215, African American total is 86, percentage of white is 79, percentage of African Americans, therefore here you can see is 11.03, which is pretty low. African American men is 9, African American women, there are 62 of them, and the percentage of African American women is over here, 12%. Okay, so let's use this 9% number for African American men, and we'll find other universities are also that low. So let's click on that one. It tells us University of Alabama in Huntsville, which is also down between 0 and 9, it's a percent. And same with University of Alabama, Athens University, which is this one, is 5%. Wow, Birmingham is 6.7. George C. Wallace University is low. Also, Huntington College is 13.5. Heritage is 4.7. Jacksonville, 12.7. A lot of these are in the South, which makes sense. So this would be good data for the prosecutors to use to get more African American enrollment in Southern college universities. John C. Calhoun State University, University of Mobile, which is in Alabama, 12.87, and University of Montevallo, Northwest. Okay, for example, one of the colleges from the South, University of Arkansas at Monticello. And it tells me that I clicked on that particular university. Here are all the attributes for that particular university. Percent of African American women is 27. White men total is 232. White women is 341, which is pretty good. That means that there's more women than men. 205, 246. So let's see if any other universities that have percentage of total American enrollment here, 23. Between on 5 on either side, schools that have a total percentage of African American enrollment between 17 and 28. And I found a couple here already: Enterprise State Community College, George Wallace Community College, Huntington College, which is 23%, Jefferson, which is 26%, Jefferson State, Judson. These are all in the South, which isn't surprising to me. Now, so let's find all of the colleges that have a value of white women who's down to 30. And Alabama State University only has 32 white women. Interesting. Lawson State has only 29. Alaska Institute, which is not surprising because that's a small school. Beauty College. Here we have some more smaller schools that are only between 25 and 35 white women. And I'm going to click OK. The age of that college only have between 25 and white women. Okay, so I wanted to show you the data that we have downloaded from the Department of Education website in zip form, and how I massage the data to make it work for this project. So here is the first spreadsheet I looked at, which shows a bunch of different criteria that universities use to determine admissions. For example, ADM Con 1, ADM Con 2, ADM Con 3. They could either be required or considered, not required, or recommended, or neither. And it just got to be really complicated trying to fit all 4 of those criteria into all dozen of those admission criteria over all of the hundreds of universities. So I dumped that idea. And instead I went over to this other spreadsheet here. This one shows different enrollments based on different races. These variables across the top are the different races and genders. So you have Hispanic women, Hispanic men, Asian women, Asian men, African American women, men, etc., and white one and total. That's what these different variables mean across the top. And then the column along the left is the university ID. So then I went over to another spreadsheet, which is this one here, to get the university ID and look up the university name and location. And then I made a whole nother spreadsheet out of all of those, which was this one here that I made up called Total Enrollments Black and White .csv, which mashes together the name from that last spreadsheet, and then more English variables here with the different enrollments in the various columns. And then I made a JSON out of that. Here is the JSON that I made for each of the node letters. Here is the final JSON file that I made, and you can see that I had to use the university ID number as the key, and then as the value all of these different attributes for our particular university. I went through and manually changed this to be the key for every single record, and you can see there are 3 million lines in here, and it took me about 6 hours to go through every single one and move that field from outside, from inside the JSON to outside to be the key, and using a lot of repetitive motion. Actually, there are 6,904 universities, as you can see from the bottom of this spreadsheet, but I did eliminate ones that were under 50 and under 100 enrollment, because if for example, you wanted to see the percentage of African American enrollment, then if it's a very small university, very small college, then having one person would make a huge difference, and it wouldn't really show a pattern. We need to have larger universities to show whether a pattern exists and whether a university needs to be investigated for discrimination, for example. Okay, I also wanted to mention that I had quite a bit of technical issues, in addition to the ones I've already mentioned about MongoDB, Node.js, and Eclipse. And one thing I discovered is quickly I needed to limit it to 30 at a time on the screen. Otherwise, all the nodes are in one corner and their root is in another corner, and Arbor freaks out when it only updates the screen. And at that time, it only updates the screen once every couple of seconds. I also experimented in the nodes use a 0 or 1 alpha variable. 0 means invisible and 1 means visible, but that didn't work out either. That's the way that the original Arbor came.
Since our labels are so long, I had to increase the initializing variable of the particle system to 10,000 to increase the resting space between the nodes. The nodes initially start far apart, bounce towards each other as close as possible, and then finally end up at their resting spots. JSON can compare strings with % signs and integers to each other with no problems, but all objects have to have the same structure, and you have to convert variable types often within JavaScript since it is a soft typing language. And JSON can handle values whether they are quoted or not. That being said, it doesn't always work. I had to do a lot of search and replace tricks to get everything quoted or not quoted to make them proper JSON. So here's the deeper look at the code. The first method is letter chosen. Here you can see that it first tells you what you've chosen, then it starts creating nodes on the fly. All the nodes are green except for attributes, which are blue. Then I add them to the nodes to erase array, which keeps track of which nodes are on the screen. That way I can erase them later when I change screens. There's no such thing as an erase all or clear screen method with Arbor, unfortunately. Then I have to use the hasOwnProperty method because each JSON object has many more attributes than the ones I've created, including lots of metadata. But only the attributes I've created have their own property. If they have their own property, then I add the school I found to the system, which displays them. And then I add them to nodes to erase, so I can erase them later. Now here's the schoolClicked method. It's the second method I'm created. I also use the hasOwnProperty method again inside there to iterate through the attributes of the school that was chosen. Then I make a new attribute node, which is blue this time, and then I add it to the system and create an edge from the school to the attribute. Then here with the attributeClicked method, which is the third method, I split each attribute on the colon. The amount before the color is the key, and the number after the colon is the value. You can see data, key, value, which is 2 layers of redirection. That's the most complicated code in this whole project. Then I compare to see if the value of each attribute is between 5 below and 5 above the given school's attribute's value. The fourth method is rootClicked, which happens when you click the root node. This just creates all the A through Z nodes again, so you can see schools that begin with that letter. So that's a quick overview. I really enjoyed this project. I love experimenting with different ways to seeing patterns in big data. If you ever need anything else done like this, I would love to do it. Thank you again.